Hello, ladies and gentlemen. Welcome to the third part series. This is the third part of the series of videos where I teach you how to set up multiplayer for Kinematic Character Controller. This is Server-Authoritative with client-side prediction movement. And in this video, I will teach you how to set up your animations. Let me show you the final project so you know what you will be creating. First, I have 3 clients. I am going to run the first one as the server. I will join as a client. Now, as a client, I am able to see my character moving. Now, the character is moving with animations, and as you can see, the animations are working for the server and the client, and I will be able to connect as another client, and client number 1 can see the movement of client number 2 as well as the server. Everything is perfectly synchronized. Even the jetpack is synchronized. So if you wish to learn how to do this, then stay tuned. I will teach you how to implement animations for Kinematic Character Controller, Server-Authoritative, and client-side prediction. Let's get started. So far in our series, we have implemented the topology for client-side prediction and, well, server-authoritative movement. I am going to run the game as a server. I will join as a client, and so far we have been able to move whatever input we pass. It's working. Whatever you do for the Kinematic Character Controller, from this point on, it will work. And then, if I join as another client, well, here we are moving along the game. Now, these are capsules. In capsules, could be what you are aiming for, but mostly you want a character which is animated. So we are going to now animate a character. So in this video, we are going to do that. Now, to do this, first of all, we need a character, we need some animations, and we need a lot of willpower. So let's get started. For the character, we are going to use Cinti assets. So let's write Cinti in the assetstore.unity.com, and you can use, well, you can use the prototype, which is free. Somewhere in here, we have the prototype. Well, this prototype pack right now is running on a discount. Look, it's worth $2, and this is what I use. I really recommend you go grab it, okay? Because it's what I will be using on the series, but there is also a free version available somewhere in here. And let me find it and tell you which one is it. To find it, just go to the Cinti Studios, click in here, their profile, then go to sort by price, and you will see the starter pack, and here is your character. Just download the starter pack and import it into your game. I will import the paid version, which is much nicer. It brings a few more things to the table, but eventually you can use whatever you want, because a character is a character, and Cinti characters are, well, the same in every asset. And you can use whatever 3D character you want. It doesn't have to be a polygon or whatever. So once you have your character, you will need some animations. So as for the animations, Cinti also provides the animations. You will need animations. You could get Mixamo animations, and that's another story for another time. But whatever you choose, make sure you have them, okay? Right, now, I will import my character and my animations. Going to the package manager, we go to our assets, and we're going to say prototype, and I'm using the prototype pack from Cinti assets. Polygon prototype import. You just import your prototype pack from Cinti, right now worth $2, normally worth $10, and very, very much worth. So import it, and also import your animations, okay? So I'm going to import everything inside the prototype pack. Perhaps we don't need the scenes, but everything else we'll import. So we import it, wait for the import to complete. All right, now that we have imported the assets that we are going to be using, both your animations and the polygon prototype, we will now go to our prefabs, go to your player, right click, well, double click, open it, and here you are with the player, your character, your root, and your mesh root, and inside the mesh root you have the capsule. Okay, so first of all, we are going to disable the capsule. If we disable the capsule and we click on the character, we can still see the collider. Now inside the mesh root, we are going to go to assets, polygon prototype, prefabs, characters, and of course we need to first URP extract me, import the URP fix, so import that. All right, now once the import is done, you go to prefabs, characters, and we have the characters in here. So female, male, choose whatever, with a face, without a face. Okay, so for instance, the male, we are going to drop it inside the mesh root. Okay, I don't like this one. I like the one with no face. Dummy here. Okay, perfect. We have the dummy. Right, now we can first of all right click, prefab, unpack completely, and this is your character. You can swap it. Now remove the animator that comes along with the character and leave everything else as is. You have your character. Now click on the character that is outside, not the mesh, just the character, and we need to make a fix. So we need to adjust the size of our mesh. So for this, the transform that I found works for me is 1.12. So 1.12, 1.12, and you should notice that now it fits perfectly inside the capsule. Do not, and I repeat, do not adjust the capsule collider. You need to adjust the mesh. If you adjust the capsule collider, you will break the Kinematic Character Controller. Okay, so we have added the mesh for the character, replaced the capsule with the mesh, so we can now delete the capsule. Now we go to the scene. If we press play and we just go as a host, no matter. Remember, the host is only for testing in single player because it won't work if you run host client architecture. It's server client architecture, okay? Now, perfect. You can see we have the character here. Now, of course, you need to adjust the size of the game and everything, but that's later on. Now that we have the character, we need to animate the character. All right, let's jump back to the prefab of the player. The first thing we need to do is go to character, and after the component of the locomotion controller, we are going to add the animator. Add your animator. Now for the controller, we're going to go to assets, and we are going to create animations folder. Inside the animations folder, right click, create animation animator controller, and that is your character controller. Okay, now drag and drop the animator controller, then your avatar. The avatar that you will use is the one provided from Cinti. So polygon prototype, models, character, FPS hands, no, it's somewhere in here, characters.fbx. I believe this is the one. So assets, polygon, prototype, models, characters, FBX. Double click it and perfect. Now update mode, leave it as normal, and culling mode, always animate, works perfect like that. Okay, next we are going to create an animation controller. So inside our scripts, we go to assets, scripts, character, create, scripting, animation controller. Okay, wait for it to compile and add it to your character. There you go, it's compiling. All right, it has compiled. Now I'm going to drag and drop the controller. Now that we have the controller, we are going to open the animation controller, delete everything inside, and make it a network behavior. So network behavior, and you need to import unity.netcode. Network behavior, import unity.netcode. All right. The animation controller will reference both the animator and the locomotion controller. So let's first start by referencing the animator and referencing the locomotion controller. So locomotion controller, there you go. Let's now actually do those references. So we will drag and drop the animator and drag and drop the locomotion controller. Let's first start by working on the animation controller itself. Okay, so for the animation controller, after making those references, we are going to add a few values. First of all, we're going to add animation smoothing. So let's add a header for the references and a header for animation smoothing, and this will smooth the animations. Then we will add a few floats as private. First, the private float for current forward and current turn, okay? So we add the floats for current forward and current turn. Then we will create a method that will be a helper method to allow us to clamp to 0 any value. Because when we work with animations and with axes, we will usually have like an infinity number that will never be exactly 0, but it will be so close to 0 that it is actually 0. But I don't want that. I want from 1 to 0, from 0 to 1. So we are going to use a method clamp to 0. We pass the value, the threshold to clamp, and we return the clamped value. Now we're going to define the update method. And inside the update method, first of all, we're going to check that we have provided the locomotion controller and the animator. Otherwise, we will return. Either locomotion controller or the animator cannot be null. Okay? You could also leave it like only the animator, because maybe perhaps the locomotion controller is optional. Alright, so we are now going to define a method to handle locomotion. So we are going to do private void handle locomotion. And inside handle locomotion, we're going to define the target forward, the target turn, the target speed. So float, target forward, target turn, target speed. And now those values are going to be passed on from the locomotion controller. And this is what you need to understand in this case. For this to work, the locomotion controller will need to make use of network variables. Do not overuse network variables, because for each network variable, you are adding extra information to the network, which will in turn possibly make the game laggier. So it depends on how many network variables you are using. As for the controller, I haven't noticed any lag, but keep it in mind. So don't overuse them. Only use them when necessary. So go to the locomotion controller script, and now let's define a few network variables. So the network variables, first of all, will be for speed. First of all, the animation controller uses the forward, the turn, and the speed. So in the locomotion controller, we're going to declare public network variable float, network speed percent, the forward axis, and the right axis. This will be 0 value floats. So we define the network variables, and now anything related to animation will be done inside the update method. Then anything related to animation inside the update method will be strictly handled by the server. All right? So first of all, we are going to make use of the code provided in the walkthrough of the Kinematic Character Controller. So if you go to the walkthroughs and you go to the final section where is root motion, you will have these values. You can copy them and paste them. We will now declare these values together. So first of all, forward axis and right axis. Both the forward and the right axis are private floats. So along with the target ones, I'm going to define the forward axis and the right axis as a float. Okay, then we will have the forward axis sharpness and the turn axis sharpness, which are values that you can control. Therefore, they will be serialized private, and we will give them the name of header animation. So above the private variables, below the jumping one, we're going to define a float for forward axis and the turn axis. Okay, that's the only thing that will be outside is server. Now inside is server, we define everything else. Now as for the speed, we will need to calculate the speed. We will compute the speed. So to compute the speed, after the current character state, we will compute the velocity and have the previous position. Now, as for the previous position, we will define it inside the start method, and it will be previous position equals motor.transform.position, and the same for the rotation. Now we need to define them. So for computing speed, perhaps below client-side prediction, we're going to define the vector 3 for position and the quaternion for rotation. Then inside our update method, we have defined the computed velocity. The computed velocity will be as well a vector 3 as well. So define a vector 3 for computed velocity. So far inside the update method, we are computing the velocity. We have the previous position, and then we just define the max speed. So as for the max speed, I have implemented in my game the run speed multiplier, but if you don't have it, then don't use it. So max speed is equals to max stable move speed. Raw speed percent will be equal to the computed velocity magnitude divided by the max speed. And then we get the speed percent by clamping from 0 to 1 the raw speed percent. Then if the speed percent is very small, we will explicitly set it to 0, like the clamping we define inside the animation. Now we need to actually define this, so we will pass it as a value for the network speed percent. And for the network forward and right axis, it's as simple as just setting the value to forward axis and to right axis. And since the forward and the right axis are being set inside the update method, everything is working fine. Now we can test this. So once we have those values, we go back to the animation controller and we keep working on handle locomotion. So target forward, target turn, and target speed will be equals to locomotion controller dot network forward axis dot value, and the same for the network right axis, and the same for the speed. Now we will smooth the transition using some interpolation. So the current forward and the current turn will make use of a lerp. And to do this, we do current forward is equals to mathf.lerp parentheses current forward, comma, target forward, comma, time delta times the smoothing factor we defined above. The same for the turn. And finally, we have the clamped values. So this will be clamped. So clamped forward will be math.absolute and make it 0. Otherwise current forward. So if the current forward is below 0.001, it will be 0. Otherwise, it will be the current forward. Same for the current turn. And of course, we can make use of our clamp to 0 and current turn because we're just clamping to 0. And that's why we created this clamp to 0 helper method. Okay, so now that we have the clamped values, we need to actually set the floats inside the animator. And this is how you would normally animate in any scenario. You do animator, referencing the animator we have here, dot set float parentheses forward, and this will be the clamped forward. Then same for turn, so set float turn, this will be the clamped turn. Finally, set float for the speed, and this will be the speed, which we need to clamp. So we define the float clamped speed is equals to clamp to 0 speed. And we have the clamped speed. Okay. Now, for the grounded, because we have the forward, we have the turn, we need to know if we are on ground or if we are in the air. For the grounded, we will set it up right now. Set bool grounded locomotion controller dot network grounded state. Now, I challenge you, try to implement it. It's very easy. We have already done it. All right, let's do it. Here in the network variables, we are going to set up another network variable called network grounded state. Network grounded state will be equals to a bool. So we change the float to bool, and initially it will be false. Okay, now the network grounded state will be modified inside the update method. So right below the network right axis, we can do inside the update method, of course, inside the is server, network grounded state dot value is equals to motor dot grounding status dot is stable on ground, or motor dot grounding status dot found any ground. We will now save this. We will now save the animation controller, and we will now test everything. First of all, we need to actually modify the animation controller. So we go to our assets, animations, character controller, double click, the animator window will open. Otherwise, we go to window and we search for animation, animator. Okay, so in the animator window, we have the any state, the entry, and the exit. We will right click and we will start working in an organized manner, okay? First of all, we will define the substate machine for locomotion. So locomotion. Then we can define another substate machine for airborne, where when we are on air. Airborne. But let's first work on the locomotion. So double click locomotion. Now, for the locomotion, we will define a few states. First of all, we will define movement. Okay? So let's go to locomotion, create substate machine, and we will define movement. Right, we have defined movement. Now that we have defined movement, we double click it, and we now are going to define the different movement states we have. First of all, we will create another substate machine for the idle. Okay, idle. I'm going to make it very simple for the sake of this video and to just provide you with the information you need to apply your animations. Of course, in other videos, we will go in depth in a specific section for animation, but inside the idle, we are just going to set up the idle animation. So create state, empty, and this will be the idle. So idle animation. Now, this will make the transition from any state. And the logic will be the following. First of all, it cannot transition to self. Otherwise, the animation will repeatedly initiate, causing issues. The interruption source will be the next state. And the condition will be that parameter does not exist in controller. Oh, we need to create parameters. All right, let's create our parameters. We click on the base layer. All right, we're working on the base layer, parameters. What parameters have we added so far in the code? Well, in the animation controller, we have the forward, the turn, the speed, and the grounded. So we add those 4 parameters. The forward as a float. I don't know if I added as a float. Let's add it again. Forward, turn, add the speed, and the boolean for grounded. Grounded, perfect. Now we do have the conditions. So we are idle if we are grounded, true, and speed is less than, I don't know, maybe 0.05. Something like that. Okay. If those conditions meet, then we are idle. Now for the animation, we need the motion. So that's why you need to download your animations. Here I have these animations that I can use. And we have the idle here. So I'm just going to drag and drop the idle animation. Perfect. And that's it for the idle. We can start checking. If we play the host, you can see the idle animation. Now, let's work on the movement. So, simple movement, all right? Simple movement. Let's work on movement. Of course, when you have seen my introduction, I have a lot of months applied to my character controller. That's why it's very professional. Okay, so for the movement, we are going to create a blend tree. So let's go here, movement, and we are going to create a blend tree for, let's say, jogging, all right? The jog. All right, and as for the jog, we are going to make a transition. We cannot transition to self. Interruption source will be the next state. And in this case, we're going to define the conditions. So the conditions will be speed must be greater than 0.05 and we must be grounded. And if we are, then this is a blend tree. Did I create a blend tree? No, I didn't create a blend tree. Right click, create state from new blend tree. Okay, now let's make the transition. Cannot transition to self. Interruption source is the next state. The condition is that we are grounded and that we are with a speed greater than 0.05. You will notice that if you only use the speed variable, you will run into some issues. But this is just to illustrate the point on how to do animations. Okay, now let's do the jog blend tree. Double click the blend tree and let's make it a 2D freeform Cartesian. X is the turn, Y is the forward. Now, as for the motion, we will add 8 points. Okay, so let's add 8 of these. 1, 2, 3, 4, 5, 6, 7, and 8. 8 points. All right, let's start with going forward. When you go forward, position Y is 1. Then when you go diagonally forward to the right, that would be position 1 is 1, or it would be, I believe it's 0.5, and position X is 0.5. There you go. Then when you go totally to the right, your position Y will be 0 and your position X will be 1. When you go to the right and backwards, your position 1 will be 1 or well, 0.5, and your position Y will be negative 0.5. Now, when you go backwards completely, your position Y will be negative 1. When you go now left diagonally down, then this will be negative 0.5, and position Y will be negative 0.5. Then when you go totally left, this will be negative 1, and then position 5 will be 0.5 with a negative 0.5 on the x-axis. And now for the motion, we go to the jogging, and we go jogging forward in place, and I'm just going to add it everywhere. Okay, and here you can see how the Cartesian is, the diagram starts to show. So we add all the motions, jog forward in place, jog forward in place, jog forward in place. There you go. Now we need to move these values a little bit, so it's 0.75, not 0.5. 0.75 and 75, 75. Replace the 0.5s with 0.75, and we can even fine-tune these a lot more. So I think this is it. 0.7 perhaps. There's a lot of tweaking in here. All right, let's now test this. So we are going to play as the server. We are going to open the other two clients. We join as a client, and as you can see, the client and the server, we jog, and it works. Well, my animations, of course, could be better, but it works. Now, the other client, if you experience this kind of lag, don't worry. It's just because my computer cannot handle everything that is going on. So let's now build and test. All right, for the build, we're going to go to project settings, go to player, and now give it an icon if you want to. The resolution and presentation will be windowed. Provide the default screen size and width. I'm just going to leave it as is. Use player log, resizable window, yes. Visible in background, yes. Allow full screen switch, yes. Force single instance, no, not in this case. And that's it for resolution and presentation. Splash image, other settings. Color space, linear, graphics, static. I believe everything in here is how it should be. Your scripting backend, I tend to use IL2 CPP, but don't worry, just leave it as mono. It won't make any difference for now. Then API compatibility, leave it as is, and that's it. We can now test the build, I believe. All right, now press Control B, so you can actually pop up the build. So inside your game, I tend to create a folder called builds. So I keep everything inside the game itself. So this is the builds, and inside the builds we can select this, or maybe you can go even further and say Windows, because this is for a Windows computer. Select this folder and start the build process. It will take a while, but don't worry, just wait. All right, now we can test. So in the folder of your game, go to the builds folder, visit the Windows folder, and open the application. I will open 3 applications so we can test server and 2 clients. So we have here 1 client, right? We have 1 client, we have another client, and we have a 3rd client. There we go. Now let's test. Let's run as a server. We run as a server, we run as a client, and as you can see, there's no lag, animations work, And of course, you need to work on your animation blend tree, the values, everything. This is just to teach you how to actually have your animations working. If you put on a little bit of effort and months of work, hard work that is, you could eventually end up with something like I do have in here. This will be a online course I make for the channel. Of course, will be for Udemy, and you will be able to learn how to correctly animate, aim, combat with body and with your weapon of choice. You will implement everything that is inside Kinematic Character Controller, even the crouch, slide, modified slides, so you can run and jump and slide through things. You can run and aim. You cannot run backwards because nobody runs backwards in real life. And of course, everything is synchronized across the network. So this is an incoming online course I will create with a complete tutorial on how to implement first perhaps a platformer game, and then we can move on to an RPG, open world, whatever. This is the class of topology that you would normally see in an MMORPG. So if you do have the power to host something like that, you could perhaps turn it into an MMORPG, because you are running server client topology, and that's what you normally would do in a RPG server. So that's it. I hope you enjoyed these tutorials on how to implement multiplayer. This is a video I've never seen on the internet, and I hope you really enjoyed it, because I really enjoy doing this. I see you on the next one.